Morning, sir.
We have agenda time. Warning, because I just can't think of the word, but I just walked into the wrong room in which I saw Warren, which made sense. But then I saw Dave Tonka, which didn't make sense. And anyway, Warren said, "Oh, if you have time in Dprive, maybe we could present something." And so he's apparently going to send me slides right now. So if there's like open mic type at the end,
There is, because we only asked for like an hour and they gave us, of course, the whole morning.
Okay,
So, if we asked for 2 hours, they would have given us none.
so I'm not sure how fast Warren will turn this around or even what I'll be presenting, but apparently I need time.
I will be presenting slides for Warren.
Exactly.
That none of us know what, including him. Okay.
So we'll see how that goes.
Okay.
I'm learning you to the fun.
Okay. There you go.
On-demand presentation time.
Warren just can't quit us, I guess.
I know.
All right, good morning, all. I guess we'll slowly get started here. I've run out of tea to drink, so I guess the day will have to begin for us. So welcome to Dprive. It's Tuesday morning? Yeah, so I'm Tim. That's not Warren. As you know, Warren's got promoted to management, so we lost Warren. So Brian Haberman actually ran the BOF back in London a few years ago, is stepping into his shoes. So treat him as well as you, I guess, treated Warren and myself.
Or better.
Terry, our AD, is back there, so complaints, criticisms, etc. You know where to find the man. We asked for like an hour. We didn't think we'd have a lot of stuff, but of course, they gave us 2.5 hours. So, I guess we can have stuff to go on. So we'll go through the quick agenda, sort of give you a rundown of what's going on, things of that nature. We need a jobber scribe, if we can find one. I know I asked for one. I never heard anything back. And a minute taker, if I can find one. Mr. Hoffman, thank you for taking minutes. So, and jabber, Dan, thank you. Thank you for that. So, is there another one? So that's the new note well. I actually updated the text. I didn't think I was going to do that. So you all have to sort of follow what the new text. I actually didn't even do a diff to figure out what the diff change was. So I was just proud of myself that I managed to update it. So hey, it's tough work. Fill in the blue sheets. So actually the room filled up a lot more than I thought. So at least you can tell us, tell us the secretariat how many microphones we need. So we'll go through the agenda. We've got a couple updates on something going on, some current working group stuff and some new stuff, including something that I guess Warren just can't quit us. I guess he just told Mr. Lawrence that he's got some slides he wants to send to us to present, even though he's not here. So that's Warren for us. So we'll see where that goes. So the big thing we wanted to talk about was the TLS profiles draft, which is in ISG review. Got a lot of feedback from the ISG. Of course, they're really great at that. What we sort of pushed on the list about was there were a lot of changes, a lot of editorial stuff, but some content stuff. And we wanted to make sure that we saw working group folks, sort of like, yes, I've read this and this is not crazy. So perhaps a little show of hands. Have anybody read the latest version with all the different changes? Okay, so I'd say maybe a half dozen or so. That makes me a little squeamish. We want to go back and talk to we want to get the ADs to basically lift their discusses, but they're going to want to see some more folks in the group that basically have read it and say, yes, this is good, so if you have a chance, look at the diffs, sort of pass your eyes over it and give us a little bit of feedback on that. So we're kind of stuck on that one. And I think that's like the last, bit of things for that. Okay, Mr. Hoffman.
Paul Hoffman. So I did read it, I did send it to the list, and what I want to emphasize to people is there's a lot of diffs.
Yes.
Okay?
That's
normally when the ISG sort of looks at things, and it's like we want a little bit of clarity here, you add a sentence here, or you didn't cover this, you add a paragraph here. This was bigger than that.
Yes, it was.
And so please don't assume that it's fine. I read it, I thought it was fine, but a lot of people disagree with me a lot. So it's worth the time to read it, to read the diffs and to read the whole thing again, because in fact, it's different than what we sent the ISG.
I agree. And I disagree with you, Paul, all the time, just on standard principles, but I agree with Paul that it is a lot, and it took me a while to sort of go through and make sure that we were all on track there.
Stefan Batsmeyer. I disagree with Paul this time because, there are a lot of change if you take into account the number of characters that are different, but most of the change are, in my opinion, detailed. Most of the IESG remarks were, in my opinion, mostly on matter of details.
Yep.
On when they were more serious, it was about side problems. For instance, or the whole discussion about DHCP was a distraction, because in the draft, DHCP is not very important. It's something to do in the future, etc. So the fact that it has been modified a lot is not really important. So it's always good to have reviews, but in my opinion, the draft didn't change a lot.
Okay.
Francis Dupont, I can say you should contact the review bodies like the Senate review team just to get another reviewer. I was a reviewer for the Senate, so just ask as we have a new version, so we come back to get another reviewer, so we get more things.
Okay. Thanks. So. Okay, it's good. Yeah, there's a lot of diffs, and it has changed some, but as Stefan said, some of the stuff was basically clarifying that we're not going to care about certain things. But I do think it's important for us to move that forward. And I think, I know that before we go back to the ADs to sort of have them push on their discussions, we want to feel confident that, we've got some good consensus going on here, that people have sort of done that. So thanks on that. So also we're going to talk about is Alexander's going to talk next about the padding profile draft. And Brian and I were discussing this yesterday, and this is something to think about in sort of the discussions. We have 7830, which is basically the padding draft, the padding RFC. Do we fold these two together to make them one RFC, make a biz, which is just one RFC that has the padding as well as the profiles? Or do we have two different things, right? And so that's just a discussion point, something to think about, sort of thing, right? Rather than giving implementers two different things to work on, give them one. But, there's just options for you guys for you folks to talk about. Next one. What else are we? And I know that Christian is going to talk briefly, talk a little bit about the DNS, or a quick, sort of different way of looking at the sort of the privacy thing. And so we wanted him to sort of come up and chat for a few minutes and give us that, because there's a lot of DNS over dollar transport stuff going on right now. And so it's good to, sort of have some folks look at that. And on that sort of topic, Brian and I, we're going to sit down with some of the ADs and some of the other working group chairs later this week and sort of discuss all the DNS over transport things that are out there, and sort of, how do we juggle all the various pieces, and where do they all sort of go and play and stuff like that. So we're, there's a lot of stuff happening there, I guess is a good way to put it. So, and then Dan is going to talk about his little DNS demux idea. So, and he can, because he gave us slides at 2 a.m. So, he's allowed to now talk. And we may have a final presentation with David Lawrence talking about something that Warren has going to do some slides for in another meeting. He's going to send them supposedly, but, you know, and we'll give him that former chair privilege for one time only. So, and then we had left a lot of time for an open session because we want to talk about this step 2. I know Stefan had worked on the step 2, you know, the first pass of a document, and we've had some good discussion on it. But, you know, it's going to take a little bit of sussing out as to where, you know, where are our next steps and where does the group think we're going to go, sort of thing. So it'll be sort of good to sort of have a more free-flowing type discussion in that regard. So, you know, yeah. And I don't know if anybody's been playing with the TLS DNS stuff that's on the IETF network here, but I think if anybody should, we should be. So if not, we should be ashamed of ourselves. And one of the things that I know from an operations person, you know, that's my fault in life, is I think about this, is are people deploying this? Are people trying to use it? Where are they kind of running into problems? That kind of thing. So, you know, we want to see, as we go to the next step, I think the next thing, as we start to think about phase 2, people are going to easily push back and say, well, so how is it working operationally in phase 1? You know, that kind of, you know, I think that's a big thing, you know, and so really, where do we go from here? So we only asked for an hour, we got 2.5. So, you know, I don't think we'll use the whole time. You all may think otherwise. So surprise us, or don't surprise us, you know, it's early. So that's all we sort of had. So with that, Mr. Mayor, what's that? Oh yeah, that. I guess that's the sign of doing too many slides. So good catch. It has. I'm sure you've done it. Yes. So you're up, sir.
It's Dan, you were just commenting, as Jabber described, that there are people who are remote. So if you do come to the microphone, please do make sure to say your name. Thank you.
Thank you, Dan.
Morning, everyone. How do I hold it? That way up, that one? Okay. Good morning, everyone. So I'm going to talk about the Dprive padding policy, and I think what I want to mention. Well, no, let's do it towards the end of the session. So document status. Actually, -00 expired in June. It was totally my fault because I should have updated it by the time I left Chicago. I actually didn't. So I was a little bit worried that the ID submission system would not allow my 01 version since the 00 was expired, but well, it got through. So I posted 01 2 weeks ago. Actually, there's just one significant change in the document, which is that the document now contains a recommended strategy. Yeah, I'm going to talk about that on the next slide. And there were some editorial changes. The document text is still pretty rough, so before we push that to publication, we would still need to clear the text and probably reduce some of the text regarding the strategies. So I got a little bit of feedback on the mailing list. The first one that I got was that we should also mention the strategy to pad to the maximum message size. I can add that in the next version. Paul said wording seemed fine, blah, blah, blah. Shane actually said that packet counts is maybe more important than actual packet size from an operational perspective. I can say anything to that because I'm not from the operations stuff. And in private feedback, I actually got a question, why don't we do random padding? Because that person said that random padding would actually prevent an analysis on block counts. So if you see a pattern with 1 block, 2 blocks, 2 blocks, yeah, is that worse or better than seeing some kind of random padding? So, but that goes actually back to the strategy. And so the major part of text that's new in the draft is the recommended strategy. That's based on Daniel's great empirical analysis of the impact of padding on actual traffic. So if you haven't read it, check out the slides below. They are from the NDSS workshop in, I think, March, yeah, or February. So what he did is actually he looked at real packet traces from the SurfNet resolvers and he applied a simulation of padding with various strategies to those packets, and in the end came out with a recommendation that's essentially that you should pad the queries to a block size of 128 bytes, yeah, and you should pad responses to 468. And also there's a third recommendation. He found out that it doesn't really make sense to pad a response when the query was not padded, because the signature of the queries when unpadded is so easily distinguishable that it doesn't make sense to hide the responses anyways. I think still we would probably need to discuss this, because from the conservative side, I could still pad on the server side even if the client didn't pad. Anyways, so the most important thing is how did actually Daniel select that pair? And as I said before, what he did, he essentially did a shootout of all the various padding strategies with a cost function that he defined to both ends, so to the attacker and to the defender. So, and this is sort of like the curve of the optimum strategies in terms of a certain costs ratio between attacker and defender cost. So the cost function, as far as I understand, of course, that's critical to the understanding what the actual impact is. So the cost function is, as far as I understand, for the strategy that he recommends, which is 128 bytes on the client side and on the query side and 468 on the response side, is that essentially means that about 93% of all packets have the exact same size, yeah, if that's correct. So 1.0 would mean that all the packets have the same size, yeah, and the strategy that he recommends would mean 93% of all the packets have identical size. Great.
It's slightly more complicated than that, but that's close to it.
I'm already waiting for you to walk up to the microphone so that you actually do my work. So
Yeah, so
As you did before.
the way that I did the follow-up cost, sorry, this is DKG. So the way that I measured the follow-up cost is slightly more complicated than just what percentage of packets have the same size. It's actually assuming an attacker is interested in a random packet. What are the, if you pick that packet, if there's a set of query response pairs that an attacker might be interested in, which is all of the query response pairs that you get. And so if we pick one of those at random, how many other queries are likely to be in that same, to have the same size signature? So it's not just that 93% are in the same bucket and then all the rest might be totally in different buckets. The fact that the other ones are all in roughly 2 or 3 other buckets actually increases the score as well.
that strategy sort of, or that cost function sort of assumes that it's good to have as many as packets as possible in the same size bucket, sort of.
That's right.
Because the private comment that I got on them after posting my draft would say, like, if you randomize it completely, yeah, wouldn't that be better than rather like having a pool of packet sizes? So, I mean, essentially, I don't know, yeah.
Yeah, well, so I can speak to that. I actually included random padding policies. If you, there's a list on the right-hand side of that slide there. That slide is, I'm happy to do deeper explanation of how that was calculated if folks are interested. But basically, every hourglass shape on that slide represents a padding policy combination. The query padding policy on the bottom and the response padding policy on the top. And they're color coordinated. Sorry for those of you who are not able to see colors. But some of the padding policies that I experimented with were actually randomized padding policies. And perhaps I didn't choose the random padding policy that your private feedback person said, was thinking of. But I picked some that seemed plausible and reasonable to me, and I didn't actually see that randomness gave any benefit for the cost functions that I had defined. So doing this work made me think a lot more deeply about what it is that we want from padding, and I'm happy to have that conversation with folks who are interested.
Yeah.
Yeah, I would like to support what Dan said, and also implementing random padding is. Excuse me, I'm Christian Wittmer. To support what Dan said, there is another issue about random padding. It's that it's much harder to implement right than the pad to the next boundary.
Yeah.
And it's very easy when you try to do random stuff to have them kind of pseudo-random and actually leak information.
Okay, thanks.
I can also, in the course of looking at the different random padding policies, I noted that the DNS crypt work included some random padding. And I believe one of those strategies up there was a rough approximation of their work. But one of the things that they did with their random padding, and this is something that hadn't even occurred to me until I looked at what their code was doing, was that the client sent a nonce with the query.
Oh, okay.
And the server had its own secret state upon initialization, and it chose its random padding on the basis of a combination of the nonce and the query, specifically because they are not protected against replay attack.
Yeah.
And they observed that an attacker who could do a replay attack with the DNS crypt query could just, if it was random padding, see what the random response was from the server by sending it several times, and you can narrow it down to what's so there's like surprising things that happen when you do random padding, depending on the cryptographic protections that you have from the rest of the structure.
Okay, thanks. So in terms of the document, yeah, I mean, of course, the basic function, the basic question is, are we happy with the recommendation that we have right now? Yeah, that's right now in the document. Do we need to do more research? If we need to do more research, is anybody like volunteering to do that? I think what we should actually research would be like the cost function. Yeah, is that the cost function that we need? Of course, it would be interesting to hear someone from the attacker side. Yeah, I'm not seeing them volunteering to reveal that kind of information. Furthermore, there is of course a trade-off, as we have seen on the previous slide, between the bandwidth cost and the follow-up cost. So is the sweet spot that Daniel chose the right one? Yeah. What's the reason for that? And of course, other field data. We had data from one reasonably big precursor, but it might be interesting to look at other data. And something that I came up in a hallway discussion yesterday, if we feel that that's the best knowledge that we have at that moment, but we could like find out we have a more reasonable strategy in the near future, we could actually declare that document as experimental, yeah, which also would answer your question regarding rolling in the padding policy into the RFC 7830, because I think essentially I think it's not a good idea, because the padding strategy could actually change quite quickly if we found out that there are other forms of attacks against the padding size. And I think that 7830 is pretty stable. So there's not a lot that actually can go wrong with that. Well, so the other questions with regards to the document is, do we want to keep this description of the strategies? Do we want to like compress that a little bit? I can add a little bit of more strategies, like, as we said, pad to the maximum size. And we need reviewers, because there are a lot of to-do words in the draft yet, and nobody like complained about them yet. So, and of course, why 468? If it's a draft, if it's in the document as the recommended strategy, we need a little bit of background text on that. Yeah. Christian
Ritema. Well, first, I mean, let me support your point about not merging the documents, because the second point I'll make is that the padding strategy actually depends on the transport that you use.
Yeah.
If you use, for example, TCP, it's entirely possible to pad several queries in a single, say, TCP or TLS packet, at which point you have to consider the effect of padding on this series of packets rather than just one. And I am suspicious that basically the padding strategy that you end up with is different in this transport like TLS or QUIC for that matter than it would be if you are doing UDP. So I think that what we have here is a fine specification when you're doing UDP, but you might want to have a bit more studies if you're doing different transports.
Yeah, good point. Sorry, Christian, go ahead.
And so I mean, that's more support for the idea of keeping those policies separate. But it's fine work, and I would like to see it published. I mean, I don't want to either. I also do not want to delay it on the basis that we might learn better when we do other transports. But it's a fine strategy for now.
What you just said came to my mind that Daniel, I think we discussed that in the case of TCP, padding shouldn't consider the 2-byte TCP message header, because in case that falls exactly on a block boundary, you would like to be able to reverse engineer whether the original DNS message was like on the edge of a block size. Yeah, but I haven't added to the draft. But you're right, Christian. I would need to add considerations for well-known transports at that time. Yeah, I have no idea about Quick, so we would probably need to update that in the first place anyway, as soon as we have more transports.
Or at least define this as UDP.
Yep.
Yeah, so
Whatever works out.
for UDP, it's a very good strategy.
Yeah.
And it's probably applicable for the DTLS without it in change. It's applicable. It's a very good start for TLS anyhow. And so if you don't know any better how to do that, it's a good recommendation. But that's.
So let me add another question to the questions I have on the slide. What are the transports that are in scope for that document?
I would think focus on the UDP, because that's what you're probably going to be deploying on first, right? But maybe determine.
Let's be clear. I mean, padding mostly makes sense if you also encrypt.
Right, of course.
Yeah.
Okay.
So it's TLS. TLS is the trans. Well, yeah, TLS is not UDP. Yeah. I mean, it can be, but. So essentially, that document that we have would apply to DNS over TLS. Yeah. Which is again not UDP.
Let's track back my previous remark. Padding also makes sense for DOS protection. That's basically, if you can do padding of your query to the expected size of the response, then you get some built-in DOS protection.
Oh, you mean like proof of work in a way?
Because well, like if you have a policy on the server that you will basically send a TC bit if the answer if the response is larger than the query.
Yeah, that's a whole separate.
But it's a whole separate use of padding.
Still, can you use send text about that to the list?
Okay,
Because
so
it's
basically
interesting.
what I say is that you have this problem. It's the same problem as DNS cookies. It's the same problem as other things for DOS protection. Sure. Okay, you don't want to have a UDP response to be larger than the UDP query.
Okay, I get your point.
Okay, because that provides for amplification. So in the absence of a three-way send check of some kind, you may want to use padding of queries to the size of the expected response, or to some large values at 1200 bytes or something, so that basically you remove the potential for amplification, for those amplification in the responses.
That's a use case that would actually be forbidden by 7830, because based on several comments from the working group, 7830 currently says that you must not use padding if the transport is not encrypted. So we had a couple of comments around that, because it is useful for monitoring and for probing, essentially MTU probing, for example. But based on the feedback of the working group, we currently have in the RFC that you must not use it if transport is not encrypted. Which,
okay.
I mean, the network wouldn't forbid it to do it that way, but technically we would need to describe that, and that technique that you just described would need to update 7830.
Yeah, so this is DKG. I think Christian's proposal is an interesting one, but totally disjoint from the work that's going on here. I support keeping this as a separate draft. I do think that it's relevant for DNS over TLS, just because it's the best that we currently have. I am despite being the person who did the research to come up with this split here, I'm under no illusions that this is perfect. And in fact, that what is the best padding policy may change as the network changes over time. So I think it's important that we can say, here's the current best policy. And one of the things that I observed in implementing this, we have padding and these default paddings already implemented. Do you have an implementation slide?
I don't, that's my
So-
last slide, but I think it's in Node, isn't it?
Yeah, we actually have patches in several free software DNS recursive resolver clients and servers already using this particular recommendation. And one of the things that I observed in doing one of the implementations is that this is something that can be done unilaterally. And you can just have the default policy, and then when you upgrade your library, you get the new default policy, which, you know, when someone else does better research than mine, which would not be hard, I'm happy to share what I've got if anybody wants to do it. Then you can just upgrade your library to get the new best recommendation as the recommended policy changes. So I'm happy to see this as a starting point. I support publication, and I would also be super happy if somebody wanted to immediately revise it because, hey, they've got better data.
Thanks.
Hi, this is Shane Kerr. So yeah, I find this topic endlessly fascinating. And I basically agree with everything Daniel just said, which we don't know basically what the right approach is here, but this seems like a really good one. But we also need to be humble and be ready to change it, because one thing I think that a big piece that's missing is we haven't heard from any cryptanalysts about this. I think there may be strategies that can be used in terms of getting the end user to do certain kind of behaviors by getting them to make certain patterns of query to make it more easy to identify them. Like if we can convince a client to send some queries that are on the edge between our block size, we might be able to discover them. I don't know what these kind of techniques are, and I don't know how they're going to extract signal from the noise. So as long as we recognize that there may be attacks like this that we don't know about, that's why I think experimental is probably good for this. As long as it doesn't get in the way of implementers actually using it, because frankly, we are being experimental here. We're going into areas where we don't have really good recommendations. So, and that's it. And a final minor thing, I also, because of the packet count considerations, I do think we should tweak the block sizes just a little, so we get as much into the packets as we can. I think it can only make it a little bit safer, and even if it doesn't make it safer, it doesn't hurt.
In which direction, or in what
I
way?
think we should make the recommendation 500 byte block sizes, so we can get 3 in a single 1500 byte Ethernet packet. So not a big deal, but
Yeah.
sure.
But we had a discussion yesterday because
So there's crypto overhead in each packet. And so you need to account for some amount of cryptographic overhead when the thing is encrypted. So we're talking about having the clear text size up to roughly 1400. If you get 3 468s, you get 1402. And that leaves you a little bit of room below the common MTUs that people encounter for your crypto overhead.
Cool, okay.
unfortunately, I was looking for a picture yesterday, but unfortunately, nothing really significant happened in the year 468, and also there's just a bus line in London with that number. So.
Stefan Bartmeyer speaking. I think that the document with all its advice and strategy is basically okay, and we should move forward. If we don't have, of course it's not perfect, but if we don't have a RFC, there is a risk that implementers will start to design their own padding strategies, which is almost certain to fail because it's not obvious. In the document, we have data. We just have a theoretical analysis. We have data thanks to DKG. So we can be reasonably confident. And anyway, it's better than the strategy that people take out of their mind just like that. So I think we should move forward. Yes, I will send a review.
Oh, good. That was the next thing I was going to ask for. So a couple of questions. I believe the experimental idea is probably the best way to go forward because we do have some. Go ahead.
A quick comment to that. I think that it's actually required because if DKG's work is actually non-native to the draft, yeah, then I think we would need to go to experimental because the standard struct document wouldn't allow us to
exactly
refer to that presentation.
Because I think people are going to experiment and see what is the best policy and that kind of thing. So unless anybody violently opposes that, I believe that's probably the best way forward on that. And you know, the topic of sort of merging was more of just a, you know, it wasn't like, oh, we think this is the right answer, but we see the difference. You know, 7830 is a very simple, straightforward document. And this is definitely something at some point down the road, as this thing kind of maybe sort of, you know, coalesces, you could sort of see that happening where implementers had like just one draft to basically sort of build and sort of, you know, and here's like sort of the best way to sort of attack it. But yeah, definitely
It was more of a discussion point, just to make sure people were sort of paying attention this morning, sort of thing. So, and so I did hear from Stefan, he agreed to review it. We'd like to get actually a few more folks to review, if we can have some show of hands, so folks to review. So I see Sarah, I see DKG, I see Mr. Lawrence, I see Christian, who's in the back there? Shane, Paul, can you, I'm writing these down as well.
Olafur, yeah.
Oh, so way in the back, okay. So we appreciate that. It was Sarah, Christian, Lawrence, DKG, Shane, and who's way in the back? And Olafur way in the back. So, and we can hold them to it, sort of thing. So, but yes, I do like where this is going, and so I think with some cleanup and folks sort of addressing some of the to-dos, yeah, we're looking pretty good. So, Mr. Hardiger.
Yeah, Wes Hardiker, USC. One thought that just occurred to me is that in DNSOP, we're about to try and push forward a whole bunch of stuff that's going to change sort of the possible packet sizes. So trying to pick a sweet spot may change as time goes on.
So that's a good point.
Another reason to keep it
Those
experimental.
pesky DNSOP people. So
I did that.
okay.
Actually, I have a question for Daniel. So the draft you have that is listed here, does that include the methodology that you use to generate the graph?
So what's linked there is a set of presentation slides, which does include in sort of presentation format, but not in textual format. I would be interested in having enough time to write this down in sort of like a more sort of LaTeX-y formal paper that describes it, but it does describe the formula used for the follow-up cost, the formula used for the bandwidth cost, and how the combinations were done, and some visualizations of the underlying data. So it includes a bunch of that stuff, but it is in presentation format and not in like a draft format, like what we would be used to seeing. Given that we can do SVG, I hear, in RFCs, maybe I could put it into an RFC draft or something, but I'm not gonna, like, I have a lot of other things to work on right now, so I'm not about to do that.
I was just thinking in terms of people who want to try and replicate the measurements.
Yeah, if there's anyone who wants to try to replicate the measurements, I have source code. I'm happy to give you a copy of. Maybe I'll even just clean it up and publish it, because I think that would be useful. If you've got data, if you run a recursive resolver, I can give you a specification for what kind of data I could run the code on, and you could just give me the data. I only need counts of the packet sizes, queries, and responses correlated without any other information. I don't want any other information. But so if you run a recursive resolver and you want me to run these experiments on your data, talk to me. I'm happy to do that, and then we can have a second data set if people are interested. I'm also happy to have people take the code and run with it and do their own adjustments.
Thank you.
Thank you, Alexander. So I believe, Christian, I believe we've got a few. What happened to the clicky thing? There's the clicky thing. You get the clicky thing.
Good morning. So I have been working, my name is Christian Huitema. I've been working on Quick and on DNS privacy for some time. And I'd like to present here the work we did on DNS over Quick. Just a short fan first. I mean, who knows about the Quick protocol, what it does, and how we can? Cool. Cool, that's nice. So, how does it work? Yeah. So, the quick transport, basically, the IETF is standardizing a version of Quick, which is an evolution of the work done by Google before. The difference between Quick and transport like TCP or TLS is that Quick does pretty much what TCP and TLS do, but it does that in a single implementation, which is typically implemented inside the application as a library. And that allows for a lot of flexibility and allows for a lot of work. The two functional difference between, say, TCP, TLS over TCP and QUIC is the availability of zero RTT transmission in some cases and the availability of parallel transmission so that you can have multiple streams. So for example, if you're doing HTTP or QUIC, you can open one stream for one HTTP request, another stream for another one, and the answer can come in parallel without having one waiting for the other. So basically what you get is a high-performance transport that incorporates the best of what we know about TCP so far and this business of parallel streams, which is pretty handy when you have a transaction-based protocol like DNS. So big features, zero RTT on resumption. That's useful for a DNS transport because a classic problem with, say, DNS or TCP is the fact that if you maintain your connection too long, you create a lot of overhead on the servers. If you make them too short, you create a lot of overhead again because you have to reestablish them. What you get with availability of zero RTT is that your policy can be much simpler because the cost you pay for reestablishment is much lower. You don't have this overhead of waiting for the handshake to complete before you can forward a query. You can forward it immediately. And so it becomes easier to do a policy that says, well, instead of having something complex about I have to wait a long time or I have to do some code, if you get it a bit wrong and you cut it too soon, it still doesn't matter very much because you can reestablish it very quickly. The other feature is head of queue blocking. So head of queue blocking is the idea that if you lose one packet, say in TCP, you will only deliver the packet that was transmitted after that, after the packet that you lost was corrected, because TCP effectively serializes all those transmissions. It turns out that when you do DNS, the DNS traffic is very bursty. I mean, the process by which queries are generated is very bursty. The queries don't come one and then one sometime later, etc. They come in small batches. So if you have a small batch and you lose one part of the batch, then you are delaying the whole batch. Whereas if you have this parallel processing that QUIC enables, you can just repeat the one that was transmitted. That one gets delayed because it has to be corrected. But the other one can be processed immediately and resent immediately. And that's a big win. That gets you effectively what you get with UDP otherwise. You have retransmission efficiency. Well, that's the difference between, it's basically on par with TCP in terms of a modern TCP, selective acknowledgement, etc. But it's better than UDP. One thing we notice on UDP is that the retransmission process of UDP is end-to-end. If a query doesn't get responded to in some time, you retransmit it. That sometime has to scale with the end-to-end processing of the query. So, for example, if I do measurement on my client, I observe that several queries will be answered immediately because they are in the cache of the resolver. But many of them, and it's typically more than half, have to be sent over the network, and the answer from the recursive resolver comes after, say, 100 or 200 milliseconds. And that means that your UDP timer has to be long enough to allow for retransmission to allow for this long processing at the resolver before you get the answer. On the other hand, if you do something like TCP or QUIC, your retransmission can be as short as your RTT to the resolver. So the retransmission with TCP or with QUIC is much more efficient than the retransmission with UDP. And the next thing is the long messages. If a message is larger than the MTU, with UDP, you basically have to have a strategy of falling back to TCP. And that is not a problem with QUIC, because QUIC, like TCP, supports message of arbitrary lengths. In fact, we have a problem that the length of QUIC is too arbitrary, because the theoretical length of maximum length of a message with QUIC is something like 2 to the power 64, which is basically means that you have no limit. And that means that we could have DNS responses, which will be, say, a gigabyte. That may not necessarily be what we want to do, but it's security of QUIC. It's the basically one. QUIC does a normal handshake for the first connection and a zero RTT handshake for the resumption. So it provides you the same kind of basically proof of origin by three-way handshake as TCP does. It also provides you the same encryption and authentication processes as TLS. In fact, the implementation of QUICs that we have now, the specification, relies on TLS 1.3 and AEAD, so basically the same as TLS 1.3. So that's the features, and those features are interesting. If I do a comparison table of the various transports that I can think of, and I look at those features that I want for my transport, okay, I see that basically the connection setup time is the best with UDP because there is no connection whatsoever. All the other transport have a handshake, either a TCP handshake or the TCP and TLS handshake, or in the case of DTLS, the original handshake to establish the session keys. QUIC has that, but it has that just once, and then you can do zero RTT resume. So QUIC is not quite as fast in connection setup time as UDP, of course, but it will be most of the time as good as UDP. You can have also the next feature is head of queue blocking, which is really a pain for TCP and TLS because of the batchy nature of the arrival of processes. So that is solved with UDP, it's solved with DTLS, it's solved with QUIC, but it's not solved with the other one. Retransmission efficiency, I mean, basically here, the classic end-to-end retransmission gives you worse performance than something based on an actual organized retransmission. And long messages where the UDP-based protocol have to fall back. Then in terms of security, you need to have the three-way handshake. And yes, you can bring back the three-way handshake with UDP. I should have a column for UDP plus session cookies, which will give you the three-way handshake. But then in that case, if you do session cookies in UDP, then you lose the connection setup time issue because I mean that means that you have to pay for that handshake. And encryption. So basically, if you look at those 5 columns, you see that QUIC is the only one which is green all the way. And that's a nice sales pitch, isn't it? Yeah. Now, let's add a caveat to that nice sales pitch, okay, so that nobody panics. All of those don't happen to be useful very often. Like the connection setup times, it happens once every 200 transactions about in the classic TCP thing. So it's largely amortized. The head of queue blocking, it only happens when you have a conjunction of a packet loss and a burst. So it's basically based on your packet loss rate, which is not normally very high on a good internet connection. Retransmission efficiency is the same thing. It only matters if you are actually losing packets. And long messages, the best statistics I have on long messages is they happen on once every 1,000 transactions or something like that, that you have to actually use the truncation because of the message is too long. So if instead of doing that, you plot the response curve of the various transport given the same load, they are almost the same. I mean, those differences are nice difference, but they are almost the same actually for a stub to recursive, because the parameter that matters most there is the latency between the stub and the recursive. That latency is typically very small, and so all that gets compressed, and you don't see that. And the difference are lower than the difference in response time between the chain of processing that happens between recursive and authoritative. Which means that, for example, what I conclude there is that of the two scenarios that we have, Quick is a nice fit for the stub to recursive scenario, but most of the potential gains are in the recursive to authoritative scenarios, where all those parameters become suddenly much more important because you're on a wider network with much longer RTT. Phil.
I proposed doing something very similar to Quick before Quick. My big concern there was making the resolver entirely stateless, in that the way that you set up a large DNS resolver is that you have a bunch of independent machines, and you do not want to have any state in the system whatsoever, because every piece of state requires you to switch packets along the same path. So the big showstopper for me for TCP and for any TLS system was going to be that if I had to guarantee that all the packets ended up at the same server, the cost of my implementation of a very large resolver was going to explode by an order of magnitude. So for me, the big advantage of doing Quick is I can have a completely idempotent resolver. I don't really care at all about the resolver to authoritative loop, because the way that you do that in a really large farm is it's completely decoupled, except in the case that you're doing a request for something that you don't have in cache. I don't wait until, I have a cache of DNS requests. I don't, when one of those things time out, I will prefetch before it times out. I don't wait for somebody to ask and then do an on-the-demand cache load. So my entire interest is actually in the client to resolver loop. The resolver to authoritative is out of band and not in the critical loop.
Yep.
So I'd like to see on the Quick side, can I do that idempotent, completely stateless loading? I'm pretty sure you should be able to. It might require a bit of trickery and a deeper understanding of Quick than I have already, but that to me is the real payoff.
Yes. In fact, that's a very good question. If you look at the feedback from deployments, you see that very few people deploy DNS over TLS, over TCP, let alone TLS. And the usual reason for that is because running a server with a large number of TLS of TCP connection tends to be much more expensive than running a server with just processing datagrams. One of the questions there, as Phil says, is whether we can have an implementation of Quick that reduces that load on the server. And the motivation for me is that I believe that we'll, in any case, need to do security. So we'll have to have some state, if only to manage the encryption and things like that. But can we minimize the cost of having that state? And the beauty of Quick there is that Quick is implemented in application processes as a library. And that means two things. That means that you can experiment with different implementation so that you can very quickly change your library. You don't have to wait for an update of your underlying operating system to get a change in your stack. So that means that you can be much more agile and try new stuff. And the other thing is, because you do that in a library, you don't necessarily have to have a one-size-fits-all API on your transport. So you can study the API to your transport in such a way that it does minimize the handling of state and the cost of handling state that Phil was mentioning. So,
Subodh Iyengar. So currently, as Quick has specified, so echoing Phil's point, that I think that the stateless case is very important, that resolvers should be able to handle DNS responses in a stateless way. So the current way that Quick is specified is that one UDP packet corresponds to one Quick packet. And so encryption is done at the Quick packet layer. So what that means is that the first UDP packet, which is the TLS13 client hello, so it is the currently specified, it's called the client initial packet, has to be in a separate UDP payload from the first encrypted packet, which is the request. So since it is across multiple UDP packets, that necessarily implies that we have to have some state for some amount of time to handle that transition between payloads. So there's a current proposal out there, and I've also echoed this, for being able to shove multiple Quick packets into one UDP payload, and that would be really useful for this use case, and that I would really encourage Quick to take a look at that.
Absolutely. And in fact, that was one of the big motivation we had to start this DNS over Quick effort, was precisely to see what that tells us about the features we are missing in Quick that we should have. And what you describe about being able to pack several encryption frames in a single UDP packet is clearly something we might want to explore.
Ian Sweat, Google. I was mostly going to echo the fact that, yes, I think there's already an open issue on the GitHub for, trying to do this. And I am fairly certain it's going to happen, partially because it would be beneficial for HTTP applications as well, even if it's a minor optimization. And so that seems valuable. And then the other thing I was going to say is I wouldn't discount the fact that the head of line blocking advantage versus TLS over TCP. When I just pulled up some tail latency numbers, 95th percentile on DNS resolution even today is like not too terrible, but like you start getting to like 97 and things go like very, very bad very quickly.
I have similar simulation curves, and what they say is that basically your curve, if you take your classic cumulative frequency distribution curves and you see they're exactly the same up to the 95th percentile for all transports. And then you do see differences. And if you assume a 1% loss rate, for example, in both directions, you see that the difference happen like in 5% of the case, between 95 and 98, TCP will be slower than UDP because of head of queue blocking. And then from 98%, the 98% part of the curve to 100%, UDP will be slower because of inefficient retransmission.
That makes sense.
That's
so we get hopefully the benefit of both worlds.
And Quick will be on top of both of them. Yes.
Ben Schwartz, Jigsaw. My only concern about this is that what I really want from this is to be able to multiplex this with other services over Quick inside the crypto context, inside the ciphertext stream. If I have to run this on a separate port, for example, from other Quick services, then that defeats a lot of the confidentiality advantages. In particular, it allows network operators who already interfere with DNS to continue interfering with DNS by forcing clients to fall back to insecure DNS. So it's important to me that we figure out a way to do this that doesn't just, for example, run Quick on port UDP 853.
No, not on port UDP 853, but we can discuss that. Do you want me to respond first to Ben?
Sure.
That's actually one of the questions. There is a use case that says that we should do DNS over HTTP for various reasons. Okay, and yes, then if you define your DNS over HTTP, you inherit DNS over HTTP over QUIC whenever HTTP moves over QUIC. And that's the thing that gives you the maximum stealth, because it's indifferentiable from your HTTP traffic. And you can do that. And if you assume that that one of the HTTP servers that you're contacting can also be your DNS server, then you get that kind of stealth. There's a flip side to that. And the flip side is that if you do that, then you require DNS server to implement a complete HTTP stack, which increases the size of the code, the efficiency of the code, and the attack surface. So that's a trade-off, and we'll have to experiment and understand that trade-off.
I'm not saying that we should require HTTP implementation. I'm saying I want to be able to multiplex this within a quick context in parallel with HTTP optionally.
That will be basically something that we need to do in the QUIC working group. If we were to do that, the way to do that is to set up a QUIC connection that supports multiple ALPNs, and to have a mechanism in the QUIC stack to identify which frames belong to what ALPN. That's something we may want to do in the QUIC working group, albeit not now. Yeah. Yes.
Alex Mayhofer, by the way, I like the title of that slide, QUIC over DNS. It seems like DNS becomes the new super substrate for TLS and for QUIC, so world dominance soon, yeah?
Yeah.
More to the point of the various proposals that we see floating around here. I'm talking about Paul's draft regarding HTTP DNS, or HTTP over DNS, of course. Yeah. So it reminds me a little bit of the RTP, encrypted RTP thingy we had like 10 years ago. And
just 10?
I think so. So I think we had 12 versions of how to do encrypted RTP, and that was that XKCD comics that said, oh, we need to do a 13th one. Yeah. So I think we should like invest effort into agreeing onto a limited number of transports. Yeah. I know that there's always market. Yeah. Even it's not relevant to the IETF usually, but so I'm a little bit careful about, this is a smaller group, and if we invest all the effort into a single transport, that's maybe more efficient rather than rolling out 3 or 4 transports. On the other hand, I assume that the implementers of the potential software that would use DNS over HTTP, or HTTP over DNS, of course, they have much more resources than we probably have in the working group. So, yeah.
No, I think you're reading the notes I have here. So,
okay.
So I was going to get to that once we got through the line sort of thing. So,
So most existing deployments, at least even ours, deployed in stateless mode, and it's like request response immediately, and we only deployed in ours. I mean, doesn't QUIC seem kind of heavyweight for that purpose? Like, that is, we're trying to shove a QUIC server now into a DNS server, and then that seems heavyweight. That is, we're trying to solve all the problems at once. I would actually like to see a solution which kind of is simple and works for the DNS case as well. That is, like, I'm a stateless server and I want to not make that many modifications to my DNS server to actually have encrypted transport. So in terms of, yeah, like QUIC exists, it provides the properties that we want, but it is like, it provides a whole host of additional properties that we might not want. Not sure what we're going to use them for, but.
Well, and basically the answer to that is implementation experience.
Yeah.
I
Okay,
agree.
and
Yeah.
at this stage in the game, there are a lot of questions of efficiency of servers, efficiency of the implementation, etc.
Yeah.
And we can have a theoretical discussion, or we can have comparison of implementation. And I would rather have the latter.
I agree.
My name is Andrew Sullivan. So let me just preface this by saying I think that Quick is pretty promising for our use cases, and I'm pleased to see this work. But I'm a little nervous about the way you framed this, the sort of stub to recursive versus recursives or forwarders or whatever to other stuff. And the reason I'm nervous about it is it goes back to actually when we made that decision in this working group in the first place. When we decided to tackle things that way for privacy considerations, it was really a tactical decision that had to do with the kinds of things that we figured we could do and who was going to be private and so on. If you think that the purpose of Quick is really just to enhance privacy, then this would be a reasonable split once again. But I don't think that that's the only advantage here. And I think that the plain fact is that if we embrace Quick, what we're doing is we're introducing a new transport for DNS.
Yes.
I'm very, very nervous about splitting the DNS protocol kind of permanently into the stub to recursive versus everything else. The protocol doesn't really work that way, and there are a number of ways in which in which the symmetry of the protocol is lost if we start making that kind of division.
Yes.
So I would be uncomfortable actually with tackling things in this way, and I would really actually much rather just say, okay, new transport, we're gonna do the whole thing. That of course now creates like a whole bureaucratic problem, because I don't think this working group is very well chartered to solve the problem that way. But that's just sort of IETF mechanics, and surely we can work around that. But I really am quite uncomfortable with this split.
Yep.
Yes, when I do measurements of performances, okay, because I mean, a large part, I mean, there are two motivations for Quick: security and performance. When I do measurement of performance, it appears that if you look at the distribution of your query response time, about less than half of your queries are served by your cache at the resolver because of TTL management and all that. The other half, obviously, you see a tail of response time that indicates that obviously it has been going to the internet to find a query, recurse, etc. And those have a much longer delay. So if we think about performance, we have to consider the potential performance gain on the wide internet scenario, which will be your point. It's basically the transport for DNS. And I think that people understate the issues with UDP retransmission, because the UDP retransmission is very inefficient. It's typically, you have long timers. And because if you do this resolution for the internet, you end up with a chain of resolutions, like 7 CNAMEs from some CDN providers and things like that. I mean, look behind you. And that means that you have many opportunities to lose a packet and go into this inefficiency of the current transport. So there is actually a strong motivation for having something more efficient on the wide internet. At the same time, one of the resistance to that is that if you do the natural choice today would be to use TCP, then your servers become very inefficient. So you have this trade-off between efficiency and performance, which is really what we want to explore there.
So there's a small problem. This is Andrew again. There's a small problem in the way you just described that, because you're only talking from the perspective of one side of that communication. But the problem is, of course, on the other side, the servers have a different set of trade-offs with respect to efficiency and overhead and all the rest of that. The retransmission things are actually non-trivial for the server side as well, because of course, under conditions, and given where I work, but I'm not allowed to talk about them. The plain fact is that that hurts on the server side as well. So I think that there's a whole bunch of considerations there that really actually need to be analyzed at the outset, because if you do this only in the first hop of this potential hop by hop protocol, you can make decisions in there that are not going to carry through. Maybe that's the right answer, but at that point, we're talking really about a new protocol. I'm not sure we want to accidentally create a new, DNS BIS kind of fall into it.
No, you're right, and as I said, I mean the performance issue, the performance difference at the first hop are basically commensurate to the latency of the first hop and to the frequency of errors. So that means that they end up to be a very small part of the overall problem.
Phil Baker again. So responding to the previous but one speaker, somebody did actually propose doing a simple UDP transport that was custom to DNS in the original meeting proposal. And the reason it was rejected, I think it was 3 years ago now, was that this was work that was very important and had to be done in 9 months. Yeah. Which is one of those, spec smells. Whenever I've been in a standards meeting where somebody has said, we've got to do this fast, so we've got to do it sloppy, they've never, ever met their schedule. The reason that I prefer quick over what I propose now is twofold. One of them is quick exists. People are going to do quick over DNS. Sorry, people are going to do DNS over quick. Yes. Yes, actually, people are going to do DNS quick over DNS. Sorry, as well. But yes, quick is rapidly becoming the new SSH. Yep. It's it is going to subsume everything, and so that's one reason. The other reason is that there are very few people in IETF who really are going to propose a new cryptographic protocol. If you look at the number of proposals that have been accepted, in fact, the number of proposals that have been made, there are very few individuals who've ever proposed a new cryptographic protocol. Most people are not happy doing that. You need an incredibly large ego. I had to, it had to, well, believe it or not, you propose a new crypto protocol, you are going to get a huge number of knives in your back because you are the target, and very few people want to do that. No,
you're right. Look,
yeah. So
there is a high bar for new cryptographic protocols. There is a lot of analysis going on in the current TLS 1.3 track. It's much better to reuse what we have than to guess that you might be better.
Now, the subtle part that originally came up to, I think that what you're going to find, following on from what Andrew said, we are going to effectively change the DNS protocol no matter what. Because the DNS protocol is now, 30 years old. The spec is awful.
It's younger than me.
It's it is written in a it is worse than your typical draft. And there's a lot of things that it doesn't actually say that nowadays you would have to state. And one of the things that is implicit in the protocol that has been imposed as an operational constraint, but is not there as a protocol constraint, is the length of responses. The length of your request is effectively bounded because the request format, they blew it, so you can only effectively have one request. The protocol allows multiple requests, but because of the way the protocol is written, you can't actually use that. So it's one request per packet, and that limits the size of the request. The way that we've limited the size of response has been purely that the infrastructure will blow up if you try and create DNS record sets that are too large. And one of the things that you're going to end up doing, regardless of whether you use TLS or Quick or whatever, you're going to take away that limit. And that limit has to be there because we're talking about bootstrap for discovery. And so you do not want that infrastructure accepting indefinite, unbounded length payloads. Actually, I think that the protocol limit is about a megabyte or whatever.
In Quick?
No, DNS. You could, in theory, have a DNS record set that reaches about a megabyte because you can have 2 to the 16 response records, and then each of those can be about,
Okay, so Phil, is there something that we are doing that we should be doing different?
I think that what I want to see in order to understand DNS over Quick, I'd like to see some documents that actually give me the wireline and what it actually turns out to be. I'd like to see some traces, and then I'd be able to understand it a lot better. Because at the moment, I have to read the Quick documents, which are a moving target, and then I have to read the DNS documents. If I saw that in a document, I think I'd understand it better.
Okay.
Olav Guemerson. Thank you, Christian. This is the second time in this working group that I start questioning the existence or reason for DNS. Basically, what is DNS? Is it the wire format? Is it the protocol? And actually, it is a wire format with 2 protocols embedded in it. It is the question. And the way we select between the 2 protocols is by use of the RD bit. And what you are exactly pointing out here, there is a difference how you communicate with authoritative server versus how entities communicate with the recursive resolvers. And so I think this is perfectly reasonable that we have different solutions on these different hops. So I agree with you, and I disagree with my friend Andrew.
Okay. And David Lawrence, I agree with my friend Andrew. That's why I got up. But then also that last point that Phil just made, I want to speak in support of that would be quite useful to actually demonstrate, hey, this is what it's supposed to look like on the wire. But the main reason I got up was to say that my own interest in DNS over Quick always started out right from the beginning, even though having responsibility for both very large authoritative server operations and recursive server operations, that it was the authority that drove my particular interest. And I think that starting to, form people's ideas around these are separate communication paths, even though that there is a conceptual note of truth to that, I don't think it's really useful to split that out as being 2 different ways of looking at the DNS, and that.
Okay, we're gonna stop after Stefan. So I have some things we want to talk about on this side. So
yeah. So anyway, I think Andrew's right.
Alex Mayover. We have too much time, so the discussions are interesting. Well, thinking about it again, I think that Quick over DNS, of course, is very interesting because what we see in other areas of protocol design seems like TCP is like coming to be, I'm not saying towards the end, but the use might decrease in the next coming years. So it's quite natural that we also look at something that's not TLS. Yeah. So I think it's an interesting thing, and going 10 years into the future from now, I'm really curious of whether that will be the dominant protocol for DNS or TLS. I would rather bet on Quick over DNS, of course.
Okay, thank you.
Stefan Bartmeyer speaking. I won't go into the details of DNS over Quick because I don't know Quick well enough. And anyway, my remarks are also for DNS over HTTPS. If we follow this path, we will have 3 possible solutions for DNS encryption: DNS over TLS, DNS over Quick, DNS over HTTPS, which will create 2 problems. One is a practical problem. The resolver or the DNS client will have some difficulty making the right choice, which one to use so we will need a meta guidance for the client. And the other problem would be a marketing or public relations problem. What message do we want to distribute outside? Because we face a big deployment problem. I mean, it's not enough to write a RFC on implementation. We need to have some deployment. Then we have to tell people, okay, you care about privacy, use this and that. And if we have 3 different solutions, that will require a lot of effort from the IETF community manager.
I'd sort of stop unless it's quick. Unless it's quick over quick. So
It's very quick. Set everything aside. I think whatever we do with regards to a new transport for DNS, we're gonna run DNS over UDP on port 53 for about as long as we run that 64.
Exactly. So, yeah, yes, thank you for all that. The part of we asked Christian to sort of present it, but mostly as a different sort of privacy thing. Our big thing though is our concerns are, Quick is still a moving target, right? So we're sort of trying to hash out a lot of things that they still haven't kind of hashed out in the protocol itself. And I know in reading the draft, there's a lot of questions and to-dos and things like that are sort of framed in there. So there's still a lot of work in progress. And I feel like we're trying to get ahead of the Quick horse kind of thing. I think, I think it's a little premature in some ways.
Well, part of the reason for doing that now is to inform the development of Quick.
Yes. So yes, you're trying to basically help them. If you're going to do Quick and we want to do DNS over it, please consider these considerations sort of thing, which is, I believe, what a few things that sort of came up. I think, I heard earlier sort of thing. Yes. I think it's early for us to sort of sit there and say, oh, let's go deploy a bunch of stuff over this.
Oh, no.
Yeah.
No.
Yeah. I mean, I think we'd all be crazy.
Basically, success for this in the short term would be to have experimental implementation doing measurements and comparisons. And I would expect that to happen in the next 6 months about, okay? Once we have this measurement and comparison, then we will have several iterations of the draft and doing that, okay? So my goal here, the presentation here was really to get feedback and get people to cooperate and send us their requirements. And in particular, I'd very much like to have cooperation when people running big servers about what is the cost for them, what are the buttons that we have.
Yes, and I think that's what I was thinking, and I just didn't want us to sort of get away from that and sort of go into the minutia of the various things that, may or may not actually be, an issue in, a couple months as they sort of, the quick draft sort of settle out.
I mean, the discussion about whether we should have one version of Quick or one version of Sheet or something, that's something I would expect happen by, say, London.
Okay.
Alex Mayover. While it may be tempting to solve other DNS issues while adding confidentiality, Dprive is not the working group to do this. That's what in the current charter. So if we do something like this, we would, I suppose, require a significant rechartering.
Yes, and I don't think we'd actually kind of felt that this was something that we would actually bring into the group. It was something good to discuss, as sort of another sort of, here's someone out, here's another sort of way of attacking the privacy. Oh, our AD is going to stand up. Oh, glorious one.
Terry Madison, responsible AD. It's great to have the discussion, but the discussion absolutely does not stay here, end here, or be siloed here.
Exactly.
It's much, much broader, encompasses some of the things that Andrew mentioned, some of the thoughts that I have as well, which many may not agree with, and it's from an architectural sense and from the understanding of being a root server operator. So there's an expansion here. Great to start it here, great to have discussion, but keep working, keep thinking. Thank you.
Exactly. There's a lot of the solid, minds of people doing privacy and DNS and stuff here. It's a good place to actually have sort of some of that discussion, but it's not going to be the end result, right? So we figure this will sort of go out into the quick groups and the other places, and you guys will sort of seed the IETF with good ideas, hopefully. or just quick over DNS.
Yeah.
You know, that's, okay. So, okay. I've got these slides from Warren. So I did get the slides from Warren. And we'll try to figure out how to get those in there. And we'll show those, maybe we'll figure that out after the Mr. DKG. Yep.
Hello, I'm DKG. So this is a presentation about this is sort of informational about something that I've got working and would be, and is functional. So I'm looking at demultiplexing DNS over HTTP. This is sort of motivated by Ben Schwartz's comment at the mic earlier. It was motivated by the same question that Ben had. So currently we have these two different protocols. They're tunneled under TLS. There's HTTPS, which has plain text HTTP tunneled under TLS on port 443. And we have DNS, the TCP variant, tunneled under port 853. So I want to ask, what would the network adversary do if they don't like protected private DNS? And the answer, of course, is that they would try to just block port 853. So I was looking at that and said, how do we defend against that? And in the obvious arms race, we simply want to squat on port 443 so that the network adversary can't distinguish between our traffic. However, if you have your name server running on a well-known, on an easy name for people for configuration, people like to type that stuff into their web browser, and then you get, so like this. This is a web browser that's looking at a web service running on port 443, HTTPS. This is a real thing. It's out there. And hey, why can't we do the same thing also on port 443? This is a DNS query over TLS on port 443. I don't know, can you guys see my pointer? Do I have lasers? Can I shoot you guys with lasers? Yeah, so port 443 TCP right there. So this is the same server running at the same time. Nothing has changed, and it's simply doing both HTTPS and DNS over TLS. So how does it do that? Well, the difference is that we look at the clear text packets and we just demultiplex on them. Turns out there's a pretty easy proof that for HTTP 1.1 and DNS, you can guarantee that the clear text of the initial frames are distinct from one another. The proof is in the draft, which you're welcome to read, but you can distinguish between them trivially. Here's the algorithm. Look at the first 14 octets. If any of them are in this range, then it's DNS. Otherwise, it's HTTP. Not too hard. Easy to implement. In fact, so easy to implement that even I could implement it. It's functional. It's in Debian testing. It's running on that server that I announced. So this is just an attempt to get people thinking, this is an easy thing to do. You might be totally horrified by it, but I have some explicit caveats. So this is a demultiplexing per TLS connection, not per query. So we're not going to interleave DNS and HTTPS on a single query. It only works when you're working with HTTP 1.1. Fortunately, we can distinguish between 1.1 and HTTP 2 based on the ALPN on the server side. So the server can also offer HTTP 2. The server that I've got up there right now is not offering H2, although I plan to do that. And so the ALPN will demultiplex between 1.1 and 2.2, and inside the packet will demultiplex HTTP and DNS by the complicated algorithm I just showed earlier. For demultiplexing within H2, I actually recommend Draft Hoffman or something, whatever comes out of Draft Hoffman. The DOE work, I think, would be the way to go, and that also lets you do on a single TLS connection. You can do the multiple. You can demultiplex separate queries. So this is not in any way an attempt to override that. I'm just observing that we can do this right now. In fact, we are doing it right now, or I am doing it right now. And if you query my server, you will be too. One concern is that this kind of inspection might constrain the future development of stream-based DNS or of HTTP 1.1. My understanding from the HTTP BIS folks is that there is no further development of HTTP 1.1, so that kind of constraint shouldn't be a problem. I just heard from Wes today that there may be some changes to the DNS formats, and I'd like to hear more about that. I want to make sure that if this gets more widely deployed, because hey, it happens to already be available in Debian, that we're not going to block that. If we are, I will rip it out of Debian. I don't want it to block DNS over TCP. And of course, if you try to combine this with some additional multiplexing, the approaches are unclear. So that's your horrifying idea for the day. It's functional.
Okay. You had me, Christian Whitmer. Dan, I was with you until you mentioned ALPN. Because if you have a different ALPN, that means that basically your adversaries can use that.
So, right, thanks. So ALPN is for distinguishing between HTTP 2 and HTTP 1.1. Sorry, I just heard a no shouted out from the audience. In the context that I'm talking about here, the adversary can look on the wire and they can distinguish, the adversary can distinguish between HTTP 2 and HTTP 1.1.
Yes.
The DNS over TLS connections will offer either no ALPN or the same ALPN that an HTTP 1.1 client would give.
And so there's the problem there is that as long as ALPN is in clear text, so it allows them to do some nasty stuff. Okay?
Agreed.
So if you have a difference in the ALPN, then you can have the same kind of evolution of port blocking and all that.
I fully agree. That's why I explicitly did not ask for a new ALPN token, because that would defeat the purpose of, right? The ALPN will become the port that the network adversary will block on. So my point here, my demonstration here is that this makes DNS over TLS indistinguishable from an HTTP 1.1 client. It does not prevent the server from also offering HTTP 2 to an H2 client, but an H2 client will be distinguishable by the network adversary from an H1 client.
Yeah, I mean, frankly, I like Paul's proposal better, but.
Okay, so my point here is this is not in competition with Paul's proposal at all. So this is a demonstration of something that works today, that is functional, which is not the case for Paul's proposal. No offense, Paul. But this works today, it's out there, and it works to make your queries indistinguishable from HTTP 1.1 queries. Paul's proposal is a better proposal. It will work better for H2. It's demultiplexing at the per request layer rather than per connection. So there's all kinds of reasons to prefer Paul's proposal, except for the fact that this is happening and functional today.
That's nice, but I think you're overselling it a little bit, because when you say it's undistinguishable, that's not quite true.
Well, there's traffic analysis and there's all kinds of other things that we can do.
And your traffic pattern is very different. And so your traffic pattern is easy to find out.
You can find it out, but you can't block it the way you can block based on ports today. With the ports, you can block it before the connection is even established. You can't block this unless you're willing to block unless you're willing to block port 443.
No, but you could block that on the first packet, because you are combining that with your padding requirement that provides a very clean signature that your message is exactly 128 bytes.
I haven't combined this with a padding requirement. You could combine it with a padding requirement, and then you're right, then there's a distinguishing characteristic. And that's a concern we should think about.
Artem Gavrichenko here. Thank you for your slides and your presentation. Let's continue the discussion about the indistinguishability of these speakers, except for ALPN. The TLS features another concept called server name indication, which, despite the huge work by Christian, is still unencrypted. And I can think of a possible tokens in the server name indication in this use case that will not disclose the purpose of a client connecting to the service. And your draft doesn't tell me either. What's the concept of hiding the server name in this case?
So it doesn't hide the server name. If you were to use the server that I have set up, you will obviously put a token in the clear text of the TLS connection, which is dns.cmrg.net. In that situation, obviously a network attacker could filter on that. If you are someone who wants to offer this on your own website, say a normal website that is not actually dedicated to just specifically DNS. This is one that I've set up specifically, but if you put it, you could do this on www.google.com. I'm not saying Google's going to do it. I'm sure they won't do it, in fact. But then you could make it so that the network adversary would have to block your web connections as well as DNS connections if they wanted to do that, which I suspect most network adversaries are not willing to do.
Okay, thank you.
Hi, Philhan Baker. What's the proposed final status for this?
I've written it as an informational draft. I have not even attempted to get working group adoption, although I would be interested if folks have suggestions for what the next steps should be. I wrote it down to document what I'm doing and what I found when I investigated the protocols to see whether they were distinguishable, and I wrote the code to demonstrate that it's functional. So I'm putting this out there to the community to make it visible that this is something that's possible and something that can be done on today's network. If you have suggestions for what we should do, I'm all ears.
Yeah, as I'm probably going to be saying on Wednesday in the TLS discussion, the set of things that people want to do on the internet and the set of things that people can do and the set of things that should be IETF standards are disjoint.
I fully understand that, and I recognize that this is a horrifying proposal, which is why I put the background for the final slide that I put.
Now,
and I would like to hear specific critiques of why this is wrong.
Okay, so what I'm looking, what came to mind looking at this is essentially you're trying to hide your tree in a forest, right?
Yes, that's what.
And so rather than picking an old forest, maybe what we could do is to hide it inside Quick, which is a new forest that is going to be growing quite quickly. And one of the things that I've been looking at in the web services world is, at the moment we layer web services over HTTP. And if you look at what HTTP does for the average web service, it basically does one thing, and that is expand the number of ports. Because you've got, instead of a URI, you can use a URI instead of the port number to distinguish between web services on the same. So maybe if we were to work out some way of systematically expressing that in quick language, we could get two things at once. One would be a way of efficiently dealing with these web services so we can get rid of this HTTP layer, which actually for web service isn't doing you any real service. And then things like this hack would no longer be a hack, they'd just be another way of doing it.
So you like to solve lots of problems at once, which
Yes.
I appreciate. This is an attempt to solve one particular problem, and you're right, I'm hoping to hide in an existing forest. It's hard to play hide and seek in a bare playground where nothing has been built yet.
Oh, well, Google's got a lot of quick traffic already, you know.
Shane Kerr. I don't actually think this is a horrible hack. I mean, okay, it's a hack, but it's not that horrible. And there are other protocols which do a similar thing. There's an SSH and HTTP muxer, which works. I don't know if you've seen it, but it's also in Debian. I use it on my server for the same reason, which is that sometimes you can only get to port 443, right? And I suspect there are other protocols like VPN protocols and things like that, which may do similar things. So I think it's a reasonable approach. I think it's a good idea. I think I think either just proceeding with yours as informational makes sense, or if you want to, maybe looking at a more general approach for this kind of thing for other protocols as well. The problem with that is that probably doesn't belong in this working group then, and how many protocols do you do and how general do you make it?
Yeah, I'm scared of trying to make this general demultiplexing document. That strikes me as work. I have other work I would prioritize above that. I'll put it that way. This is an attempt to document a specific demultiplexing between two protocols. Pairwise demultiplexes is much easier.
Okay.
So Martin Thompson, I appreciate that you've taken the time to do this and we're having this discussion. I have a suggestion for next steps, and that would be declare victory. I don't think we need to publish this as an RFC. You've already got the software running. It's out there, it's available to people if they want to do it. As Shane pointed out, there are other things that do similar things in this space, and they never came to the IETF and published an RFC either. It's great. Thank you.
Yeah.
Pat McManus. Yeah, thank you, but in certain areas. So I am like super excited about the use case. I think when we're in a case where you're talking on an HTTP port, speaking in HTTP ALPN, then the question becomes, why can't you just speak HTTP, right?
So let me answer that question specifically. The answer is existing clients do not need to be modified to use this mechanism.
Well, sure, which is
existing DNS over TLS clients do not need to be modified to do this. In fact, the client pictures that I've shown you here, this is an existing, this is not DIG implementation, and this is Chrome. These are unpatched clients.
Right, but then you create an incentive to perpetuate the use of those legacy clients, if you will, right, to stay on an H1 version of this in order to move that forward. And like, I think that's largely my concern. I'm just saying this like motivates the other work to specify DNS over HTTP, where you can do like a really great sort of mix-in kind of application of this. And I think that's got more long-term potential. I've got no real objections to this running, but I wouldn't want to be the one submitting the document to the people who do the port registration work, right? About what's going to happen.
Hi, Eric Pasquale. So yes, interesting observation. So on your part, that you can debug these this way. I guess two things. One is I think I mentioned yesterday, this sort of does depend critically on people willing to co-host web services and DNS. Otherwise, like you see the first connection and it's like obviously DNS and then you just block that SNI from that on. So, so you have to have co-hosting unless you disagree.
In terms of, yes, in terms of hiding, this is the SNI.
But even if the SNI is innocuous appearing, if their host only does this, then this is obvious.
Sure.
Right. Okay. Second thing is, while I do appreciate this sort of the observation that these are naturally distinguishable. In previous times when we've taken advantage of the fact that two protocols happen to not occupy the same sort of initial code point space, we've been extraordinarily sorry. Because it turns out to put handcuffs on both of them, and it seems that given the relatively modest deployment at present of DNS over TLS, if we want to move forward with this, it might be nicer to have some prologue that you committed to. And I'm not saying you have to like full HTTP, but to have like the first 8 bytes be something which is relatively.
You're asking me to modify clients.
I'm saying that the deployment of those clients is at this point so modest that treating them as an immutable legacy is really a pretty low value proposition. I mean, yes, if everybody in the universe were running DNS over TLS, and now we had this problem of.
So you're asking me to modify DNS clients, but not HTTP clients?
Yes.
So what modification would HTTP be willing to accept as a prologue that would distinguish the queries from?
I was essentially suggesting that you register essentially a single new, currently unused HTTP, HTTP method, right? And then you have one thing instead of having some weird coincidence of not overlapping.
But we're never going to move this forward. So it's just, it's Daniel's half-baked idea, right?
Literally baked as an idea. It's almost everything that we've ever seen presented in this working group.
Yeah,
this is functional.
Oh yeah, no, I agree.
So I'd assumed that the discussion we were having was about how this idea can move forward in some reasonable way. And I'm saying that if one thinks one is doing that, like other people want this, and to sort of say, I mean, if you really think it's important to be able to hide stuff under co-hide with HTTP, then to like chew up all that demuxing space for like this one protocol is very annoying, and there's a much simpler way to demux.
When you say all this demuxing space, you're saying we want to preserve the ability to demux other protocols?
I'm saying to the extent to which you think it's a good idea to have a mux here, then why is it only a good idea for DNS? Yes. Either it's a good idea or it's not.
So,
And I'm already aware of other protocols which are attempting to do this, which are doing exactly this kind of muxing, which is so, Ike over TLS had exactly the same situation, had exactly the same stuff about how they had this like prologue which was distinguishable. So it's like not like they're the only person want to do this.
My name is Andrew Sullivan, and I think I agree with Ecker. No, it's not, but in a particular way. And what's happening here, as nearly as I can tell, is that this is. I really strongly disagree with Martin that we should just declare victory and go home. That's not declaring victory, that's declaring defeat. The IETF is over if what we're not going to do is write down, oh, and here's another piece of like bone that we have now encoded into the middle of another protocol. Because what you're really talking about here is yet another way in which we're going to move the transport around for DNS. And therefore, the reason that that I agree with Ecker is precisely that what you've just done is said, okay, well, we're not going to publish an RFC that that documents this thing. Instead, people are just going to do it, and now we're going to demux these things in various ways. And you're using accidents of the internals of the protocol as a mechanism by which you determine what the transport is. And if we don't even write that down, then we no longer are doing any value of any kind for the internet. We're just like having meetings at various places, and we can probably stay home. So
that is why I wrote it down.
Right. So I actually think it's great that you wrote it down. I'm appalled that this is actually the way the internet is going, because it's the right answer for a particular use case, and yet it's the wrong answer for the network architecture.
Yes.
And fundamentally, that's the problem that we're facing. I don't know what to do about it, but I'm terrified at the prospect, and this is the reason that I got up, that we would declare it as a victory. It really is, to me, a terrible defeat.
So just if I can comment on that, one of the reasons that I've written this down is to document that this is a functional way of hiding metadata that protects against a network adversary. And if we do not continue to hide metadata in our protocols, this is what we will end up with. So I want people who look at this and think that this is horrifying, I want those people to be pushing back in all the other places in the IETF where we are planning to expose metadata in our protocols.
So I'm fine with that. Yeah. I think that's a great thing. But I think it's also then true, exactly what Ecker said, that at that point, this is the direction you're going to go, and you can't be just burning it casually, right? We've actually got to start designing that, and maybe actually a paragraph exactly along the lines of what you just said into the microphone a moment ago would be, like a worthwhile prologue in a document that were published that said, the reason this is a bad idea is not the one you think it is. Don't hide your metadata.
Yeah, I want to cut the line after who's ever after Philip. No, Martin. Who's ever after Martin? Yep. Oh, Richard. Okay.
By the way, I think my conclusion was do hide your metadata, not don't hide your metadata.
Yeah.
Okay. Just clarifying that.
Yeah.
Ben Schwartz. Yesterday we had a dispatch. We had DNS over HTTPS in dispatch, and there was a lot of debate about whether to and how to move forward with Paul and Patrick's draft there. I think this draft can serve as a great reminder to people who were concerned about that draft, that if we don't move forward with DNS over HTTP, you are not going to like what comes instead.
Philhan Baker. So to respond to Ecker's rant, which I think was entirely justified, there is actually a MUX mechanism in HTTP, in that we invented it when we had to upgrade from HTTP 0.9 to HTTP 1.0. And that is HTTP servers are actually required to check for the string HTTP/1.0 or 1.1. And there is normative language that actually requires them to reject any request that does not have that string. So what you could do in order to make this fully consistent would be to simply put, instead of it being get/HTTP 1.1, if you made it get/HTTP DNS, you would actually be compliant with the HTTP 1.0 and 1.1 protocols.
So I defer the proper DNS HTTP multiplexing to the draft Hoffman DNS over HTTP draft.
The Christian Wittema, and I've been listening to what Iker and Andrew were saying about architecture issues. It turns out that we have many points of multiplexing in the current architecture. We can multiplex by port number, we can multiplex by ALPN, and we can multiplex inside HTTP using the well-known mechanism and other mechanism. The advantage of the HTTP well-known mechanism is it is fully encrypted. It's also what makes it tied to, tying a lot of stuff into a single protocol, which has issues, its own issues in terms of implementations. We are discovering that multiplexing based on port doesn't work very well because the port number is metadata that is exposed to the network and allows for censorship. We might be able to multiplex based on ALPN if the ALPN was hidden. Hiding the ALPN is exactly the same problem as hiding the SNI. And it has exactly the same solutions. So if you assume that we can hide the ALPN using any of the SNI encryption tricks, then you get a clean solution there that basically you do have an ALPN that says this is DNS. And then you have a much cleaner architecture because it's structured, it has a high level point of multiplexing. So, and we are thinking here about privacy. We are pretty much hitting that point here. That's basically, we have to deal with privacy, but we also have to deal with censorship. And if we take the two into consideration, maybe what we want to do is work on the TLS protocol that says, or QUIC for that matter, that says, okay, we are going to use some encrypted token to do the demuxing. And we can do that at that level.
So Martin Thompson, you do have to modify the clients, unfortunately. Maybe. That's not what I got up to here to say. I got up to renege on my statements. Previously, after listening to Andrew, I think I was insufficiently facetious in my original comments. I meant to say thank you for your contribution. But now I'm going to say something else, which is this is perhaps one of the most elaborate threats of violence to the architecture that I've ever seen.
Yeah.
And don't.
Yeah.
So sorry, no, the opposite of thank you. Please don't do this ever again. Please don't encourage this sort of behavior in others. And maybe we shouldn't be encouraging this sort of thing in general. Your point is well made, and I think perhaps we should have just made that point rather than shipping software that can actually commit that violence.
I find people listen to the points when there's code behind it.
Yeah, true.
You were successful, yeah.
And the note that we put on our chair things was in the agenda was why again, right? Like why, and it wasn't so much like, oh, this is, I wanted people to sort of like look at this and yes, be like shocked, impressed and horrified at the same time, right? And I think people got too excited about trying to solve the problem rather than realizing there's like an architectural flaw there, right? And so I think there's some interesting stuff, but much like we have a draft in DNS op which is DNS over wire format over in HTTP, where the HTTP people said this won't work, and I'm like, I've seen running code that does this does work, right? Which should horrify, of course, the HTTP people, right? That's why there's many things going on about trying to resolve these kind of issues. That's the wire format, the one that Vixie and oh no, they were no. I had some pushback that said they didn't think it would work. It would they were. I think it was a little bit horrified as well. Yeah. So, and I think that's you know, and I wasn't saying this was half-baked in a bad way, because I have many half-baked ideas. And I think one of the things that I am probably flawed for as a working group chair is I will accept any sort of crazy idea that comes through, because I think, you know, they should be at least looked at and sort of considered, especially if there's code behind it. And it doesn't mean that I want to adopt it, or I think the working group should adopt it, but it's like, we should at least, you know, give it some sort of thought and drive, like you said, drive future conversations, right? Let's make sure we don't make these kind of mistakes moving forward, kind of thing.
Yeah.
Yeah.
So if you're horrified by it and you're in any working group that has any metadata exposed on the wire, think carefully about it and think about how you can move that metadata inside some sort of protected envelope between the peers. Thanks.
That's right. Yep. Yep. Thank you.
So Daniel, I'm going to add one more thing here is that, you know, as a researcher, I really get tired of hearing about dark data that nobody can get access to. And so if you think that pushing it forward with a health warning on it saying, look what I did, but don't ever do it, then I think we can work with someone to get it published. Just to say, don't do it.
Let me make my threat of violence.
Yeah. No, we're not going to.
No.
I'm not willing to publish this with a statement that says, don't do this.
Okay.
I am quite serious that, and I don't, like, let me also be clear. This is not my threat of violence. The threats of violence are the network operators that are shutting down traffic on the network that people need to use to communicate, potentially in some cases to survive, right? And traffic will squeeze through whatever remaining ossified tunnel we allow it, or the network operators allow it. So this is a document that says, if all else fails, fall back to this, because you need to get your DNS responses somehow. And you need to be able to get them privately. So I'm not willing to say don't do this as long as the network operators are killing traffic that they don't understand.
Okay.
Go ahead, Paul.
And super short, Paul out has read it. And as Edgar said, we're doing the same with IKE over TCP because we have the exact same problem. And you can tell us don't do this, but we're going to do it anyway because people are forcing us to do it.
Yes, yeah. That's
and the same with the IKE over TCP. When we talked about that document, they also said, please do not mention even port 443, even though everybody knows you're going to do it anyway. And I don't know how to solve this in the IETF because we're basically writing specifications that say read between the lines, and that's really bad. But yeah. I don't know how to do this better.
No, that's a good point. That is a good point. Thank you, Paul. So okay, thanks. We've had some interesting discussions about stuff that's sort of not in our charter, but I wanted a lot of the smart minds in the room to sort of, give some thoughts to stuff like that, the DNS are quick. And, Daniel's idea that, for better or for worse, things exist sort of thing. And so we're sort of, and maybe we needed the time because people wanted to sort of bite shit about the good stuff. But where do we go from here, right? We've got working implementations. Warren sent some slides that I've uploaded into the meeting material stuff about the DNS usage, and I would say the TLS stuff is pretty low, and so it's sad, as I would say. And so we should, I guess here's a good question. We should be deploying the TLS DNS over TLS. Who's actually like sort of running that on the IETF network? Okay. It's like gold stars for you guys. Okay, so yeah, and so it's sort of sad that we as our group we don't have a larger set of people that actually deploying something. Sarah.
So one thing I wanted to do was point people at dnsprivacy.org, which is a website which is tracking the deployment of the experimental servers in the wild. We have 12 of them.
Okay.
So there are servers out there that are running this, and that site has information about where they are, how to authenticate against them. We have some monitoring software looking at their status. It tells you whether they're doing QName minimization. So there is a set of experimental servers out there. I think one of the things that's stopping people using them is the client side. We're still very embryonic in terms of we have Stubby, people can use Unbound locally. Those clients need to mature to increase the adoption. So I think focus on that is what will make the change. And I think, and I'm also aware of plans to do some Anycast deployments of DNS over TLS by the end of the year.
Oh, interesting. Okay.
which would then,
Yeah.
overtake things. And I think what we need to do is get ourselves in a position to have a good client story by the time those deployments come out.
And I think getting that stuff to mature is much like being in HomeNet and listening to the discussions, Ted's discussions about, trying to deploy HNCP and stuff like that, is the more people that do it, the more things we sort of iron out all the sort of the things. So it becomes something very simple that, gets stuck in distributions rather than add-on sort of thing. Yeah.
And at the moment that site, we're just tracking the servers exist.
Yep.
And the next stage is to start picking up data about the traffic levels and usage.
Oh, cool.
So that's on the plan for that dnsprivacy.org site.
Okay.
Hi, Shane Kerr. So I have two comments about this. The first is I wonder, while it's important to understand how the protocols are being used and kind of measure our success, this isn't DNS privacy ops, right? So I think
no,
right.
But as we talk about the next steps, right? As we do recursive to authoritative, and that opens up a big can of worms. I think the first thing that would come back as anybody who ran any sort of authoritative server would be like, so how's it run, right? I'm a very simple man, right? I live in a world of a lot of operations and stuff, and so the first thing I think of is how's that stuff? Yes, I want to deploy that. How's it going to work in my giant crazy stack of stuff, sort of thing, right? And having some knowledge on that, right, is always very helpful.
I agree. I'm just not sure that with the way we're currently chartered the working group, that's actually
no, it's not. It's just,
okay.
Yeah.
Okay. And so having said that, I'll talk a little bit about the plan. So I currently work at Oracle Dyn right now.
Okay. Yeah, check that back.
Our lawyers tell me that I'm not allowed to make any official statements, but they'll be able to fire me then. So what we've been doing is we run an open resolver right now, and we're currently kind of rebooting the setup for that. And I've been pushing for us to add DNS over TLS for that, which is a relatively large, relatively well-known and well-used Anycast DNS resolver, right? But we are not willing to change our software choices based on this requirement, which I think makes sense. We have a whole bunch of other lists of requirements. So the work right now is getting DNS over TLS pushed into the components that we're using, which we're looking at and we're going to be doing. But getting software changes in open source projects and things like that, there's kind of a negotiation that has to occur there. These things don't happen overnight. Once they're there, even if all the software components supported it, we'd still have many months long of work to test it and make sure that we have our processes updated and things like that. Yeah. So, and I think we're probably ahead of the curve here. So I think looking for other people to do large scale adoption, it's going to take a long time. And I don't think we should wring our hands too much about saying, well, no one's using it and so on. And I think having the protocol space be far ahead of the vendor space and then the operator space is not weird, and that's okay.
And it may be, and I'm not saying we're wringing our hands, but and it may just be that as time moves on, quick over DNS becomes the something that people sort of actually fall into a lot faster because the software stack is more available or something like that, right?
Maybe. Yeah.
Yeah.
So one thing I thought might be worth bringing up to discuss again is that I remember in previous meetings, there was an argument that just said, we're not even going to think seriously about recursive to authoritative until we know what's going on with this, until we have data. And I think I want to challenge that as well and say, how would you define success or defeat here? And how would you really take that as input into the next step?
And it wasn't so much like we wanted serious data, but, and I think we felt that we should be able to start moving in that direction, knowing, and I think when we think about authoritative, I think of it on two levels. I think of the general person who's got, who's running second level domains sort of thing, and they've got servers running stuff. And then you've got those really, those flaky, root zone people, right? And they're another reality, right? And to actually try to effect change on that level becomes a layer 9 type issue, right? That's sort of really out of our pay grade sort of thing. So, just want to take, but no, I think we should be able to start thinking about it, but just realizing that I'm sure that'll be the sort of the discussions that will sort of come up along the way, right?
And also, I think with the deployment of something like this, it's highly non-linear.
Yes.
We're going to go through stages at the moment where experimental, and then there will be step changes.
Exactly.
And we don't know how that's going to feed back. So we can't preempt how that will evolve.
No, and yes, I agree.
Hi, Ben Schwartz. I'm somebody who cares a lot about the client side of this, and I'm trying to put work into that. But there's a time delay measured in years from like approval to make some client change, even from code is committed to like substantial fraction of users have the code, never mind are in a configuration where they can actually use it. So yeah, I don't think that we should get too impatient, and I don't think that we should be worried that the 7858 is a failure because 2 years from publication it doesn't have more than 1% of the internet or something.
Oh no, I don't actually feel it's a failure at all. I think it's a very solid basis for us to sort of move forward. And it's like you said, it takes a while, right? So it's like, are there things that we can do to sort of help sort of prime that pump in some ways? And then, as we sort of, and part of that discussion today was seeing, what else is out there in the privacy space? And, these are all sort of, I think, merged together here, in the coming, years kind of thing. So.
Alex Mayover. Since we're not offering any public TLS or DNS server for iterative servers, I don't have actual measurement data. However, what I did recently was I took the packet traces from one of our iterative servers and ran it through a simulation to identify what's like the approximate cost of running TLS. So I tried to, a lot of rough estimates in there. So what's the TLS session setup cost and so on and so forth. And I came up with the magic number 8, which means that running 100% of the DNS traffic on our authoritative servers that currently reaches us over UDP would require about 8 times as much resources as it currently does. So that's like a week. It could be like 3. It could be 25. I have no idea. I did a couple of assumptions, but it sounds reasonable for me. It's just a simulation.
Okay.
And since I only had authoritative server packet traces, that was the only data source that I could use.
I know in a previous life I did a lot of HTTP performance stuff, and there's a lot of work in that space, right? Like how to scale TCP. I think those folks have done pretty fantastic work on that. So I think there's a lot of places we can sort of lean on their expertise in that regard. But I think 8's an interesting number. I don't know if it's that high, but yeah.
Terry, I'm going to touch on something Alex has picked up there, and slightly in response to Sarah. You could probably take away that the last half of anyone measuring uptake usage over blah, 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 and just say anyone measuring. The importance of measuring and doing the experimentation on what is being deployed is for the data points for that next question. I don't want to walk into that next question blind, because that would be painful. Then we're going to have a world of bad idea fairies and a really long mic queue.
Yes.
So I think this is Shane again, Shane Kerr. So I think it's interesting that there was some estimates of performance cost on the authoritative side. I think we saw some earlier estimates of just TCP alone being a factor of 6, so a factor of 8 for TLS doesn't surprise me. I think we need to be a bit careful about that because we know that current DNS authoritative infrastructure is heavily overbuilt to handle DDoS attacks and things like that. And a lot of that cost comes from UDP. So I think we need to be careful when we throw around, frankly, very scary factors of 8 and things like that when we talk about the additional cost of security. So
a question for you, Shane. Your employer that you can't talk about has an open recursor. Do you have TCP numbers? Just TCP versus UDP, and do you guys sort of look at those and?
We do. I don't know what they are off the top of my head.
Yeah,
we can get those. Yeah.
Yeah, I'm not saying you need to share or anything, but you probably look at those and you factor that into as you build your plan.
I think you overestimate the rigorousness of the
Okay,
process.
okay,
But I can get those numbers.
Okay.
Dan York, just as main, not as Jabber Scribe. I would just echo their comments over here. I mean, whether these have anything to do with the charter or anything, the measurements of this are important because I spent a good chunk of my time in the work of deploying the protocols that are here, and this kind of measurements of any form help make the case for those things to be used. And at the end of the day, I think we all want the stuff we do here to be deployed out there in the real world. So, in the regular networks that are out there. So this kind of statistics, any kind of information can help with this. And I think the work that Sarah and the folks are doing at that is a great step in that regard. And I think if anyone else can duplicate that or provide other measurements of that, that would be ideal.
Or help fund Sarah and John to keep doing that. How's that?
That works too. All of those kinds of things. But I think that is critical because I think it does also, to Terry's point, it does help with that argument on where do we go next and what do we do with that.
Alex, me over again. So if somebody has a couple of PhD students at their hands, something that I would suggest them to investigate is whether they can start a project that does replay UDP traffic over TLS, against the name server, against an implementation, and see what the actual performance is. I know that TCP replay, essentially simulating the global internet space from a single node, is not that easy, but it might be an interesting project if somebody is looking for a PhD topic or something like that.
Interesting. Yeah, that is a good one.
So I just wanted to qualify what I said earlier. I completely accept we need the measurements and they're going to inform what we do. My feeling is that there are other problems we can solve that aren't related to the measurements and the idea of performance about the recursive to authoritative step. And we kind of stop work on everything.
Yes.
So questions of how we do authentication on that leg, we're not looking at them, and that's disjoint from looking at
exactly. And I don't want to stop that sort of discussion. Like I was hoping before the deadline, Stefan would sort of resubmit his step 2 document, just so we have sort of a place to sort of start that conversation. And I'm not going to call you out or anything like that. I'm sorry. I know you're busy. So, but I thought that was a really good place to sort of start some of that discussion. But you're right. There are places in terms of how do we do the authentication, how do we do various places like that, that I think we should start digging into. So how do we, I wanted to see if there was actually still interest in people sort of going after that, or are they just going to stick a flag in the ground and say, let's do DKG's, demuxing idea and be done with it kind of thing. So.
Stefan Bertmeyer. Speaking about the step 2 draft, indeed it expired, partly because of other things to do, but partly also because there was, in my opinion, very little discussion about it. I expected discussion, flame wars, strong opinions, and there have been very few. Maybe one of the reasons that the step 2 draft was careful not to mandate or to make a specific technique favorite. It's just a listing of all the possible solutions with some pros and cons, but not a lot. So maybe a better solution, I'm thinking of doing it, is to have a different approach than the step 2 draft, and then to propose one solution, because people may be more eager to discuss when there is one solution which is pushed behind than when there is a very open set of choices. And if I do it, my preferred solution would be to use DEN.
Okay.
DEN. Publishing the certificate in the DNS.
In the DNS, yeah.
I would definitely, this is DKG, I definitely support continued work on the backhaul links, the links between the recursive and the authoritative resolver. I'm happy to collaborate on those drafts to review them, whatever's needed there. And if I can help with implementations, I will.
Okay. So, yeah, and there was a fair bit of discussion initially, Stefan, on your draft, but maybe you're right. Maybe if you just pick some outlandish idea and saying this is what we're going to do, that will really get discussion going, right? Because then people will be like, "Oh, this is crazy." But you're right, and I do think there's places to go. What I just wanted to, I guess, I was sort of cautioning about was, we want to sort of measure, we want to make sure we have stuff so we can actually give good data. So as we start moving forward and talking to people and convincing people, oh, we should run this on authoritatives and stuff, and here's why, right? And it's not going to be a large, drain on your resources because we've done this research and stuff like that, right? So that was sort of where I was coming from, is making sure we actually
had that kind of, measurement. It wasn't saying we weren't going to do anything until something happened because, that seems kind of foolish too. So, and DNS does have a very long tail in that regard. Okay.
Giovanni Saidian, I think this kind of measurement research is also interesting for the MapRG group of the IRTF.
Mm-hmm. So I'll talk to the IRTF chair about that. We'll see. So, okay. So, and of course, I sort of wouldn't let my co-chair talk, so I apologize for that. So, no, Brian seems very much at peace right now. Yeah. So, okay. So that's, if that's the thing, I think, it sounds like Stefan's going to probably think about a step 2 draft, and you've got a few people that seem interested in working with you. I see Sarah and I see DKG. So, if others want to, please, reach out to him. Stefan's, he's very easy to work with. So, have no problems there. So, okay. Any last words from anybody? Oh, I have Warren's slides. I uploaded them into the meeting materials. And mostly they were showing sort of DNS usage of the network and also the TLS usage. And the TLS usage was very low. It was very sad, as I said. So, but not zero. So, at least there's some usage, and hopefully by the end of the week we'll see if we can get a little bit more going out of it, sort of thing. So, all right. Thank you all for coming. Thank you all for listening to all the crazy ideas. And so I always appreciate that. So,
Blue sheets.
You good, Brian? Okay. The map RPG, that's what he said. It was the map. Yeah, the measurement group. Yeah, the measurement group seems to do. Right.